This video is an introductory video to the heat exchanger experiment. The heat exchanger experiment is designed for you to be able to measure the performance of heat exchangers based on your computed value of its overall heat transfer coefficient. This unit has two different types of heat exchangers on it. There is a small scale plate heat exchanger, which is right here. Take note. Some people think that this whole unit is the heat exchanger. That is not correct. The heat exchangers are attached to this surface. So right here is the plate heat exchanger, and right here is the tube-in-tube heat exchanger. So there's two different types of heat exchangers you're going to look at. This unit itself is a control system for the water that flows into the heat exchangers. So you can actually, as you can see down here, there are hot water flow controls and cooling water flow control. So you can control the flow rate of the hot water and the cold water, and this unit actually controls the temperature of the hot water entering into the heat exchangers. So there's hot water that exits this unit, goes into the heat exchangers, and you set the temperature of that hot water. The cold water is set according to whatever the temperature of the tap water is. So the first thing you're going to do is go behind the unit. You'll see a green lever that if you go ahead and lift that, that will allow the tap water to flow through the unit. So as you can go over here and see the flow control, right now the flow rate is set to 30 grams per second. So you actually measure the flow according to the top of the bopper. You turn this knob to change the flow rate. The hot water starts flowing when you turn on the unit. So first you turn on the main switch. That turns on the pump, and then you turn on the heater switch, which turns on the hot water. So as you can tell, right now, according to this, the hot water is set to a temperature of 50 degrees Celsius, but the actual temperature of the hot water coming out of the hot water heater is at 29 degrees right now and climbing. So this unit works on a PID controller. This temperature will increase and level off at about 50 degrees. It takes it about 8 minutes, maybe 9 minutes for it to actually level off, because what happens is since it's a PID controller, it controls the heater by turning it on and off, on and off. So this temperature will reach past 50, slide down under 50, reach barely above 50, and oscillates a little bit until the temperature levels off to approximately the same temperature as the set point. Not exactly, but close. So what's happening to this unit is that the water comes out of the unit through these ports. So you can see that they're numbered. 1, 2. You can't quite see number 2, but number 2 should be labeled as hot return. 3, cold out, and then 4, cold return. What's happening is that the water, H out, hot out, means that the water is coming out of the unit, and in this case flowing into the double pipe heat exchanger. And then it comes out of this side and it gets returned back to the unit. So actually T1 is the hot water into the heat exchanger. T2 is the hot water out of the heat exchanger. T3 is cold out, coming out of the unit into the heat exchanger. T4 is coming out of the heat exchanger back into the unit. So T3 is cold into the heat exchanger. T4 is cold out of the heat exchanger. Right now, this unit is set up for parallel flow into the double pipe heat exchanger. How do I know that? Hot water going in, cold water going in. So the cold water and the hot water are going in on the same side and coming out on the same side. Therefore, it's in parallel flow. If I want to set it up in counterflow, I would have to turn off the unit. You don't have to turn off the cold water, but you have to turn off the hot water. The reason is that this tube right here is actually the hot water level. You can't seal off the hot water level because it expands, And what happens is if you go ahead and try to detach any of these connectors while the hot water is running, you could risk for this water level could just come out of the tube. So you don't want to do that. So turn it off, press it in, and gently release the connectors. Do it for the cold water too. The key is to be gentle. You do not want to force it because the system is not entirely fragile, but it's fragile enough that if you start yanking and pulling connectors out, you could end up causing a leak. So do not do that. Be gentle. So you can pull out the hot water, switch it around, and now I have my hot water in my heat exchanger set up for counterflow. Be careful not to twist and pinch these wires. If they're twisted too much and pinched, you could restrict the flow. If you can't seem to twist it around, just go ahead and turn the tube, or turn this nut that's attached to the system here, and that should be able to help you gently connect the tube to the heat exchanger. And then what you do is just turn it back on. Now, temperatures. This display displays the temperature of the water based on thermocouples that are placed within the flow of the water going through and going in and out of the hot water controller. Right now it's set to 1. That means that is the temperature of the water going into the heat exchanger. And then you click it over, you should feel it click the T2, then T3. So T2, you can see that that's the hot water coming out of the heat exchanger. You can turn it to T3 and then T4. Okay? And then what you would do is take those temperatures, turn it back to T1, change the configuration as illustrated in the lab handout, and go ahead and try to wait about 8 minutes for it to hit equilibrium again. How do you know you hit equilibrium? You hit equilibrium when these two temperatures are approximately equal, or when this temperature, the green indicated temperature, stops changing. Within reason. Some things to be careful on. If you are too rough with the knobs, you can actually cause the knobs to start spinning on itself without actually clicking. So what that does is that, as you can see, the number is displayed here. Right now it's on T1, but if you turn it gently, it should click over to T2 and T3 and T4. But if you're too rough with it, you can actually cause it to spin on itself without actually, without it clicking over. If that happens, just go ahead and turn it all the way to the left until it stops clicking and reorient it on T1. If you're having problems with it, you can ask the supervising professor to help you with this. But that's it. That's the heat exchanger experiment. Again, the key is to make sure you hit equilibrium before taking measurements. So you have two heat exchangers here as far as how the setup goes and what flow rates and temperatures to pick and what configuration, parallel or counterflow, all that should be indicated in your experiment handout. That concludes this instructional video.